Hello, this is Kevin Burke from the National Weather Service Office, Chicago, and this is part 2 of the top-down precipitation type method using the layer energy technique. And in this talk, we're going to be talking about using the technique within GFE. And specifically in this presentation, we'll talk just briefly again about the modifications that we made to the Bourgouin method. We talked about that more in lesson 1, so we'll just touch on that here. Also, just quickly how the weather types are derived with the new energy technique. And then we'll talk about how these energy grids work in the GFE setting. So first of all, the main modifications that were made to the Bourgouin method. First of all is using the wet bulb profile rather than the thermal profile. And this, of course, accounts for any dry layers that could result in evaporational cooling. And that, of course, can result in precipitation differences that the thermal profile would not account for. We also tuned the sleet liquid threshold that was originally defined by Bourgouin. Again, we talked about that in lesson 1. And the third one here was just to assign probabilities of precipitation types for a bit wider range around our defined thresholds. And this is to account for several uncertainties, both in the model output and in actual hydrometeor size. All right, so if we jump in here and talk about how snow probabilities are derived from the method. If temperatures, surface temperatures that we're forecasting are at or below freezing, and we have warm air aloft, so that means we would have positive energy aloft in our grid more than 0. If that's the case, this chart shows how the probabilities of snow would be forecast. First of all, you can see blue all the way up to about 13.5 joules per kilogram. So these are going to be what we consider some melting possible, but snow is still going to be a possible precipitation type. As you start to get above that level, snow probabilities start to drop off significantly, and when you get above about 20 joules per kilogram, we consider that total melting, and snowfall will not be included in the forecast. So here's just an example. Total melting. This particular sounding here, you can see, has a warm layer aloft, and it measured 67 joules per kilogram. And in this precipitation, there was no snow reported at this time. On this particular case here, we see very cool but very deep warm layer aloft. So deep isothermal layer, warm layer measured to be about 11 joules per kilogram. And in this particular case, snow and sleet were reported. So there was some melting and then refreezing that led to the sleet, but again, not enough melting here to totally rule out snow potential. All right, so if we jump in now and talk about how sleet and freezing rain are determined between the positive energy aloft and the negative energy in the low levels, which we see on this chart here, positive energy aloft, x-axis, negative energy low level, y-axis. We first saw this in talk number 1. These are the new thresholds that we are using in Forecast Builder to determine the probabilities of sleet in this case. So as you can see from the chart, once you get close to around 100 joules per kilogram of negative energy or refreezing energy in the low levels, this is where we're going to have our highest potential for sleet probs coming out. It is, as you can see, as you get more and more positive energy aloft, there is a slope to the line. So if you have very large amounts of positive energy or very strong warm nose, you might need a little bit more than that to get to maximize out your probabilities for sleet. Sharply decreasing probabilities for sleet below about 100 joules per kilogram. And basically that tells us that we don't have enough refreezing potential to get sleet reported at the surface. The other end of the spectrum, freezing rain or rain probabilities, if you're basically determined by your surface temperature, are going to be on the flip side of this. So basically your highest probabilities for freezing rain are going to be when you have lower values of negative energy in the low levels, and sharply decreasing probabilities for freezing rain as you get colder and colder layers near the surface, which means you get more and more negative energy in the low levels here. So here's an example. Again, this is the same example we used on the previous page where we had a deep isothermal layer. Notice pretty cold layer near the surface. If we measure the positive and negative energies in these layers, we get about 11 joules again for the warmth. So again, not total melting, but partial. And then refreeze potential is 135 joules. So more than enough to put us well into the sleet category. So in our forecast would have come out with snow and sleet, and then there would have also been a small chance of freezing rain. Again, this sounding snow and sleet were reported. That would have been the primary output from this forecast, but there still would have been a small chance for some freezing rain included as well. Okay, the main GFE grids that are going to be used for this modified Bourgouin technique are, first of all, the probable ice present grids, which are not really going to be covered in this training because they're the same that's used with the traditional max TW aloft method. So you should be familiar with those already. But the new grid here, positive energy aloft, this is going to represent your total wet bulb melting energy above 2,000 feet off the surface. And this you can consider to be replacing your maximum wet bulb temperature aloft in the traditional method. While the positive energy aloft will help determine your snow probabilities, especially if your surface temp is below freezing, it will also be used in conjunction with the negative energy grid that we'll talk about next to derive sleet and liquid probabilities. And again, as I said here, this is going to be used with your surface temperature to derive snow probabilities. Finally, the negative energy grid for the low levels, basically considered to be your total wet bulb freezing energy below any warm layers aloft. If you don't have cold layers below warm layers aloft, this grid will show up as zeros. So that will happen quite often, and we'll talk more about that later. This is going to be replacing the probability of refreeze sleet grid used in the traditional method. And again, this is going to be used in conjunction with the positive energy aloft grid to help derive your sleet and probabilities for rain or freezing rain. So just to show you an example here, this is an example of the probability, or I should say the positive energy aloft grid. And you'll notice here, it's color-coded quite nicely. There's very useful colors. So if your surface temperature is below freezing in any of these areas where you see blue, you're going to get some type of mention of snow in your forecast. Obviously, if you're near zero, that's going to be your best chances of snow. And once you get up to around 20 joules per kilogram that we talked about, you can see that is colored green. So you'll know in the green areas then, you're not going to get any snow output. You're just going to have too much melting energy to result in snow reaching the surface. So right away you can look at this grid and tell, okay, over Chicago, no matter what, I'm not going to get an output of snow in this scenario. Now, you still could get rain or freezing rain and also sleet, but that's going to depend on what you have going on in your low levels as we work in the top-down type technique. So we don't know that from looking at this, but we can tell for sure we're not going to get snow out of this particular method. Now, the negative energy in the low levels, this is an example of that grid. Notice how much of the area here is labeled 0. you'll only see energy in the form of negative energy on the low level show up when you have a cold layer beneath a warm layer aloft. Again, if those cases aren't met, this will be set to 0. In this particular case, you can see there was a couple areas you see here labeled in green where there was some very small areas of negative energy. So that meant there was a little bit of cold below some warm aloft in these areas. So again, this would not be considered to be enough, nearly enough to result in sleet. Remember, we want to really see closer to 100 joules per kilogram, or at least more than 50 or 60 joules per kilogram to even start thinking about sleet potential. So this is also another nice color curve as well, because notice we've labeled the area that we talked about as the mixed zone, where we could experience both freezing rain and sleet, as a nice purple color. Anything that you don't have enough refreezing potential is either going to be rain or freezing rain, depending on your surface temperatures. So you don't have enough refreezing potential. And then if you start getting really low values of negative energy in the low levels, you're really going to start favoring your potential to have sleet occurring at the surface. So you will easily be able to see where you will have potential problems with sleet, because if, say, in this area that we see just a little bit of negative energy, if we saw these blue or purple colors in here, we would know that we have quite a cold layer that's beneath a warm layer aloft that would support sleet. You can also, if you wish, overlay your positive energy aloft in contours over the top of this to see how your warm layer is behaving, if you wish. Okay, and then looking into the GFE aspects, that's how this is going to work, you're going to see what are called blended negative energy and blended positive energy aloft grids in GFE. These are in the forecast database, and basically what will happen is before Forecast Builder runs, these grids will be populated with hourly data out to 84 hours that are going to come out of the RAP, NAM, GFS, and Canadian Northern Hemispheric model. So it's going to be a blend of these that will come out on an hourly basis. And again, these are going to be created just prior to the Forecast Builder initiation. And then these grids will then go into the Forecast Builder energy grids that you see here, negative energy, low level, and the positive energy aloft. So if we need to change our energy grids at all, we're going to want to be editing these Forecast Builder energy grids with either other model energies, or we can do a blend of our own, as we'll talk about in the next slide. So the models themselves will also be available. If we scroll down from what we were looking at on the previous slide, you'll see each individual model. Now, in this particular example, the models are every 3 hours, which is what we have data for, but what you should see is hourly data, because it will be interpolating in here for you. So you'll have the GFS, the RAP, the NAM. The NAM's going to be hourly through 84, as is the GFS, and then the GFS will turn to 6 hours thereafter. The Canadian will be exactly the same. And if you so wish, the national blend of models is also available in GFE already. And you can see that right here in this example. But I will say that currently, the current run of the national blend is thermally based energies and not wet bulb based. So there will be some differences. But you do have the ability to use these energy grids as well if you so choose. And if none of these work for you, if you don't want a certain model, the blend itself didn't work, there'll also be a tool available under the Populate menu that will, in a sense, be a model blend for these energy grids. And this has to run on the fly because it actually blends the entire sounding and then calculates the energies on that. We can't just simply blend the raw energy grids because it will create a mess. So you don't want to do that. So if you want to, for instance, say you don't like the NAM output, you could then keep the NAM out of the blend and do a GFS, RAP, and Canadian blend for your positive and negative energies. You run that, and it will populate your forecast database with these hourly grids. Keep in mind, you'll want to do this over a fairly short time frame, maybe 12 to 18 hours at the most, because it's going to take some time to calculate. But you do have that option. All right, and then when you get into Forecast Builder, after you've got your energy grids in place, if you've already got your energy grids in place, you don't really need to do this step. But if they're not, if you want to just copy in from the blended energy grids that we talked about, you would run step 3, just like you would with the traditional top-down method. Except you can see on here what will show up is positive energy aloft. You'll still see your prob ice present, and then you'll have your negative energy low level that you can put in the database. And then step 4, again, this is very similar to what we saw in the traditional top-down method. You're going to have your choice for temperature thresholds between all snow and rain snow, and then anything above 37 being rain. So again, this step should be pretty familiar. All right, so then the summary here. Positive energy aloft and negative energy low level. Those are going to be your 2 grids that are going to be new to you. Positive energy aloft is going to replace the maximum temp aloft or maximum wet bulb temp aloft. And you can think of it as representing the total melting energy above 2,000 feet AGL. Negative energy low level, it's going to be your total wet bulb freezing energy that's going to be below any warm layers aloft. Again, remember, if you're seeing zeros in there, it means you don't have cold air beneath a warm layer aloft. So in a snow situation where the whole sounding is below freezing, you're not going to see negative energy. It's going to show up as 0. And then finally, the color tables here are going to really help with determining precipitation types. If you need to make any changes to the grids manually, you can just kind of follow the color tables that are provided. So you're not necessarily going to have to remember, oh, geez, when does snow, 20 joules per kilogram, am I going to get snow or not? That's not really necessary. You can use the color tables to help you with that. All right, so that ends part 2 of this particular set of talks. In the next talk, just a sneak preview, we'll talk a little bit about how you can look at different scenarios and actually edit the energy grids. Thanks, and have a good day.